So for this circuit we need to find the value of Ix, this current, and from that we will be able to find the value of this current dependent voltage source. So what we will do first is, if we look at this loop and apply KVL here, sorry, like that, so we will go maybe in the clockwise direction. So we will write the drops as positive and rises as negative. So we don't know what's the drop here across the 12 ohms resistance. We will just say that's V. So we have a 10 volts rise here, so that's minus 10, then plus V, because that's a drop if we go in the in the clockwise direction, and then plus 4. So from here we get sum is 0, so we get V is equal to 6. So now we know that the value of the voltage drop across the 12 ohm resistance is 6 volts. So that's there. Now what we can do, maybe I will use a different color. We will apply KVL in this bigger loop, outer loop. That way we will get the value of the voltage drop across the current dependent voltage source. So again we will write the drops as positive. So when we go in this direction, the 10 volts comes as a rise, so minus 10, then plus 6 because V is positive and that's a drop, and then 12 volts, this one, that's also a drop, plus 12, and then plus 3Ix, that's equals to 0. So we get 3Ix equals to 3Ix becomes 10 minus 18, so that's minus 8. Ix is minus 8 over 3 amps. So that's the value of the current in the other direction. Since it's negative, actual current is in this direction and the value is 8 over 3 amps. And the voltage drop, of course, that also becomes negative. So that's also in this direction, 8 volts. That's the value of the current dependent voltage source basically.